Hello everybody, we're getting ready to do lesson chapter 10 review and summary pre-calculus math classwork session. Today part 1, and you have 0 points will go into your notebook, and we got 52 points that will go onto your classwork sheet, which you should have out in front of you now. Classwork chapter 10 summary here. Name, date, period, due date for onliners and homeschoolers. Today's bell work, teachers, students. Today's bell work. Let u equal 3, negative 2, 1. And this is you should recognize these as componentized vectors. The v is 2, negative 4, negative 3, and w is negative 1, 2, and 2. Show that u times u equals the directional vector squared. And then down here for 72, show that u times v equals the negative of v times u. So prove these situations up here. Show that this equals that, and then this equals that in this space here. Give your students about 5-6 minutes, teachers. Pause your video for 5 or 6. See you and then. Okay, welcome back everybody for today's solutions to the bell work. And we have u times u here in this situation here. Here's u times u. And then when we multiply these two componentized vectors here, we get 9, 4, and 1. When you add these, you have 14. And that equals the directional vector squared. That's what that equals. And then for down here, show that u times v equals the negative of v times u. So for this, we have u times v, and then here's our matrix here, and this becomes 10, 11, and negative 8. And then v times u, when we switch it around, it becomes negative 10, negative 11, and 8. Thus, u times v equals the negative of v times u here. The negative of v times u would be negative 10, negative 11, and positive 8. And that little exercise there proves that u times v equals negative v times u. Into our classwork for today, we're going to jump right into our review here of 10.1. Find distances between points in space and find the midpoints of a line segment joining points in space. So the distance between these 2 points here, x1, y1, z1, and x2, y2, z2, given by the distance formula in space is, and here it is here, here's your formula for that. The midpoint of the line segment joining the points, x1, y1, z1, and x2, y2, z2, given by the midpoint formula in space is this formula here. So these are the 2 formulas that you use for a problem like that. And then for here, into our guided practice here, independent practice, students, this is you. We're going to find the midpoint of the line segment joining these points here. So let's find the midpoint here for this situation up here. Your midpoint here, here's your formula. Then here's our plug-in here, negative 2 plus 2 over 2, 3 plus a negative 5 over 2. 3 plus a negative 5 over 2, then 2 plus a negative 4 over 2, and we come out to 0, negative 1, negative 1 is the point, the midpoint of the line joining these 2 points here. Into 10.2, find the component forms of the unit vectors in the same direction, of the magnitudes of the dot products of, and the angles between vectors in space. So 2 vectors are equal if and only if their corresponding components are equal. So the magnitude of u, which would be u1, u2, u3, so the magnitude of that would be the square root of u12 plus u2 squared, u1 squared plus u2 squared plus u3 squared. And when we do that calculation, a unit vector u in the direction of v is u equals v over the magnitude of v. V cannot equal 0. So that would be the way that you would find a unit vector u in the direction of v. So for the sum of u equals u1, u2, u3, and v equals v1, v2, v3 is u plus v, and then we add these together, u1 plus v1, u2 plus v2, and then u3 plus v3 here. Then 5, the scalar multiple of the real number c, and u equals u1, u2, u3 is cu equals cu1, cu2, cu3. 6, the dot product of u and u1, u2, u3, and v equals v1, v2, v3 is u times v equals u1, v1 plus u2, v2 plus u3, v3. The angle between two vectors, if theta is the angle between two non-zero vectors u and v, then cosine theta would equal u times v over the magnitude u, magnitude v. And then you take the cosine of that, and then you take the arc cosine to actually find the angle measure of those. Okay, so in these exercises, find the angle theta between the two vectors. So we got u and v here, and we got the componentized vector here of 2 times radical 2, negative 4, and 4, and then the negative of radical 2, and then 1 and 2. So we need to find the angle theta between these two vectors here. Since this is on u, so pay attention up here. So cosine theta equals u times v over magnitude u, magnitude v. And when we do this, we have negative 4, and plus 8, which would be our u times v in this situation here. And then our magnitudes here for u would be radical 40, and then the magnitude of v would be radical 7 here. And then this becomes 0 in your numerator, so it becomes 0. So we have the angle between these two vectors is 0. So theta equals 90 degrees. When the cosine 0 is 90 degrees, u and v are therefore what's called orthogonal. So do the same thing down here, students, with this here. And on we go into 10.3. Use triple scalar products to find volumes of parallelepipeds. I can't say that word. Parallelepipeds. So to find volumes of parallelepipeds, the triple scalar product for u is u1i plus u2j plus u3k. V would be v1i plus v2j plus v3k, and w would be w1i plus w2j plus w3k. The triple scalar product is given by, and here it is, u times v times w. And then this would be your matrix here. This would be your matrix setup for that, u1, u2, u3. v1, v2, v3, w1, w2, w3 down here. So the geometric property of a triple scalar product, the volume v of a parallelepiped with vectors u, v, and w as adjacent edges is given by v equals the absolute value of u times quantity v times w. So in here, for number 49, find the volume of the parallelepiped with the given vertices. Here's our vertices here. And this is going to continue down into here. I'm gonna do this first part here, and then students, I want you to continue that down here, but I'll do the first part of this problem. So we have a parallelogram is determined by the three vectors with the initial point of 0, 0, 0. So u here will be 3, 0, 0. V would be 205, and then W would be 051. So once you have these here, then you can go ahead and find the volume of the parallelepiped with these different points here for your vertices. So you have 0, 0, 0, 3, 0, 0, 2, 0, 5, and 0, 5, 1. So from those, you can go ahead and find the volume of the parallelepiped. We did this in class. Check your notes, check your class worksheets. If not, email me for questions. Into 10.4, find distances between points and planes in space. So the distance between a point and a plane, the distance between a plane and a point Q not in the plane is d. D here, the distance equal to the the magnitude of projection of n vector PQ equals the absolute value of vector PQ times n over the magnitude of n. So this will give you the distance between a point and a plane, where P is a point in the plane and N is normal to the plane. Remember what normal meant? We went over that in class. And then I'm going to go into an example here, and this one's on you, students, so pay attention up here. Find the distance between a point and the plane. So here's our point, and then here's our plane. We need to find the distance between this point and this plane down here. So to do that, N is, in this situation here, is 2, negative 20, and 6. And then P is 0, 0, 1 in plane. Here's our point. And then Q here is 2, 3, 10. And then vector PQ is 2, 3, 9. This is a componentized here vector that we've calculated from P and Q here. So the way we do this is we go d, the distance, is the absolute value of vector PQ times n over the magnitude of n equals absolute value of negative 2 over radical 440 equals 1 over radical 110. And then this equals, when we rationalize our denominator, will be radical 110 over 110, which would come up with this number here. So that would be your distance there. And that is your chapter 10 review and summary, pre-calculus math. If you need materials or you have questions, email me, animatedpowerpointmathvideo@aol.com. Thank you very much.